Hello and welcome to this video on how to model your cams for the Automata project in Fusion 360. We will be making 5 of these cams. We are not going to make the hard cam, so this video will be on how to create those. So if you are a student of mine, you have already created your box that's going to be used for the Automata in Fusion 360. You have this in a project, and now we're going to start working on making our cams. So here we go. So while you are in your Automata project, we're going to make a new design. Okay. Now we don't really need to make a new component here. So we can go ahead and just start on sketch. Now, because our front view is the opening on our box, it's best if we do the right side view, either by clicking on the view cube or clicking on that spot on those 3 planes. Okay? If you like the grid, great. I personally turn it off. So here we go. So our first one is going to be not really a cam at all. It's just a circle spinner. So we're going to start by creating a disc. Now we have 4 inches of space. What we make this is not really that critical, but let's go ahead and just make it 2.5 inches seems to be a good size for this. So we'll make that circle 2.5, and there will be another concentric circle right in the middle that is the size of our shaft for us is 5/16. If you're watching this video, you may have something different. And then finally, we can finish our sketch and extrude that part to 0.25. That's about the approximate thickness of the material that we're going to use. All right, so we have our first, let's call this circle cam, even though it's not really a cam, but we'll designate it as a cam anyway. So we're going to save this and call it circle cam. Okay. Now, we're going to go in order of difficulty here. That's the easiest one to make. The next easiest one is going to be this polygon cam, because we don't really need to do any parametrics to it. So let's start a new file again. I'm going to again sketch in the right side view. And this time we're going to create a polygon. Now, in the drop-down menu, we want an inscribed polygon because we want to know what the maximum diameter ever could be to the points. So when we get an inscribed polygon, we're going to pull that guy up, and we're going to go, as you pull with your mouse, go straight right. It'll kind of snap to head towards the right. And again, now we've got a radius this time instead of a diameter, so we're going to make that radius 1.25. Now it already is a hexagon, which is what we want. Tab goes back and forth. We could make it a 9-sided or a pentagon, but we do want 6 sides. We want a hexagon. Tab gets us over to the dimension, so we want that radius to be 1.25. All right, now normally this would be black, but the way polygons work is you can actually move them around. So in order to fully constrain this, come up to your horizontal constraint and just snap on that line. Actually, you might have to hit the line first and then hit horizontal. And now it locks it down and makes it fully constrained. Second thing we're going to do is put that 5/16 hole in the middle again, or a circle that will represent that, 5/16. Enter, finish our sketch, and extrude again to 0.25. And we have now our polygon cam. So again, save, polygon cam. So on, it's so far so good. All right, now the next one's going to be a little different and take a little bit more time. So we've built this one, we've built this one. Now you'll notice that this is called, that it's got parametric dimensions. Parametric means that when we're doing parametric modeling, para means near or next to, metric means measurement. So we're going to put measurements next to each other essentially and have one relate to the other. So that's what this means. So let's talk about how this works. So you'll notice right here we have this through hole, which is going to be 5/16. We want that to be 5/16 no matter what. We've got a diameter here, okay, that I want to be, I'll call it 2 inches this time, and we can play with it a little bit later. And then the distance between this point and the center point of that circle is going to be the diameter divided by 4. So here's how we're going to set this thing up. Here we go. Let's start by again creating a new design. Okay. Now, while we are in this new design, we're going to do something a little bit different. And we are going to, let me get rid of my library here. Under the Modify tab is Change Parameters. We're going to click on that, and that's going to open up this Parameters window. Now, right now, we haven't done anything yet, so there's no parameters in here. We're going to create a couple of user parameters by clicking on this little plus symbol. Now, we need to enter a name. So the first one's going to be easy. In the curriculum, they call it nominal diameter. I'm just going to call it diameter. Our units are in inches, and now we need to insert an expression. What is that going to be? So for right now, we're just going to enter 2, which is going to be 2 inches, and it's going to make that diameter 2. Now, anything I refer to as diameter is going to be 2 inches. Okay. Now we're going to create another one, and I'm going to call that hole, HOLELOC, for location. Now I need to remember that because I'm going to have to type that in again later. And what that's going to be is it's going to be the diameter divided by 4. Now, I'm not sure why that's red. Oh, because I missed an E in there. It should turn black once you've spelled it right. So I've got the diameter divided by 4 so that when I'm looking at this, yeah, that's diameter divided by 4. That's what I want. Okay, and we click OK. Now there's going to be some other things in here that we're going to have too, but we're not going to deal with that right now. So we've got diameter that's 2 inches and the whole location, which is the diameter divided by 4. Click OK. All right, so here we go with actually building this thing. Okay, we're going to sketch as we have been before. We're just going to sketch on the right. And we're going to start by creating our outside diameter hole. And instead of typing in a number on this, I clicked on the center and I'm going to start typing in diameter. Okay, it will pop up for me and I can actually just click on it and hit enter. Now, this little f of x means that it's relating to that table. If we go back to the table, we go back to our change parameters, and let's say I make that 4 inches. Okay, notice that it will change that. Okay, because it's based on the parameter table and not what I entered. So let's go back and change that. I'm going to change that back, my expression back to 2. Okay, and we've got that. Now we're going to create our hole down here. We're going to do a couple little things. We're going to create this hole. I'm going to hover over that center point, go down here, and of course that diameter is going to be 5/16. I don't want that to change. That's why it's not in the parameter table. I want it to always be 5/16. But I want its location to be the diameter divided by 4. But first, before we do this, remember this can move around. So let's do our horizontal constraint and vertical constraint and make the center point of this and the center point of this vertical to each other. Okay, good. Now it's still blue because I haven't created a diameter or a dimension, excuse me. So I'm not sure why it's showing that black. Oh, it's blue. All right, we're going to hit D for dimension now. And now we're going to go from here to here. Click, and that is going to be whole load. So again, once you start typing it, it'll be in there, and I can type in there, hit enter, and now that is 1/4 of the diameter. Now, if I want to change things, it will change it, but let's go ahead and finish our sketch, and we're going to extrude to the same thing we've been doing the whole time, 0.25, because that's the thickness of our material that we're using. Now let me show you why this is important. Later, let's say that we wanted to get a little bit more rise out of our riser using this cam, and we've got enough room to do that, but I don't want to change the whole. All I have to do is go back into my, my modify, change parameters, and I can make this a little bit bigger. Now for demonstration purposes, I'm going to make it 5 just to show you what happens. Okay, and notice that the hole has not changed size. It's still 5/16, but its location relative to the diameter is still 1/4 of the diameter, no matter how big I make that. So I'm going to undo that last change, okay, and we're going to save this as, this is called an eccentric cam, ECCENTRIC, an eccentric cam. This kind of moves your riser slowly up and down kind of smoothly. All right, 3 cams so far. Time to start with our next one, which is going to be the pear cam. Now, the pear cam's a little bit different for us. We're going to do a different design than this kind of small little nub, which will barely just lift something up. I've got a different way of doing that. We are going to have a little bit different way of lifting it, but we will make this thing work. It's a little more complicated. All right, we want a new design. And as always, we're going to sketch on the right side. Okay. Now I'm going to set up my parameter table again. But I need to think about it for a moment. All right, here we go. So first of all, we're going to start off with the biggest part of the cam. Whoop, actually, first of all, we're going to set up our parameters. I'm sorry, so let's go modify, change parameters. We're going to add a user parameter. As we did last time, we're going to call something a diameter. And we're going to make that again 2 inches. We're going to create another one, and you just have to trust me that I kind of know where I'm going. We're going to call this lobe height. Lobe is the part that of the cam that raises something up. So I'm going to call it lobe height, HT. So LOBEHT. And now we're going to do a little different math. We're going to make this diameter and use the asterisk to say times, and I'm going to make it times 1.5. Now, we may change that later, but for now, that's going to be fine. And we're going to do one more called small arc, SMARC, small arc. And that is going to be the diameter divided by 4. Diameter slash 4. And now I've got my user parameters that I want to use. Okay, so here we go. Start by making a circle. We're going to make that diameter. Once you start typing, it'll be there for you to click on. Okay, and enter. Now in the middle of that diameter, we're going to put our 5/16 hole, just like we've been doing, 5/16. We want that to always stay the same. Okay. Now, up here somewhere is going to be another circle. I don't know where exactly the middle is going to be. I'll put it just above the height. So we're going to put another circle in here. Now, the diameter of this thing is going to be what I just called lobe height. Oh, I'm sorry. Actually, I'm not doing that. My bad. I'm going to call that the small arc. I'm going to make it a diameter. Enter. Okay. Now, I can already tell that I don't want that to be quite that small. So I'm going to go back and change my parameters. Okay. So it's the diameter divided by 4. I'm going to change that to the diameter divided by 3. Okay. Yeah, that looks a lot better. All right, now before we get moving on, this is really important because again, this circle can move anywhere. So I'm going to do my vertical constraint to make the center point of that and the center point of that aligned. Okay, now it can still move up and down though. So one of the next things we're going to do is we're going to do a dimension, D for dimension, and we're going to go from, oops, I'm making another mistake here. So another thing I want to do is I need to put a point on top of this circle. So we're going to create a point. We're going to go up here, concentric, that little X means we're being concentric, okay? And I need that point to be, again, vertically constrained, that point to the middle. I could have done here too, but just to keep myself straight. So that point is at the very top. All right, now I can do my dimension, D for dimension, and we're going to go from that point to the center, click, and that is going to be the lobe height, L-O-B-E height. Start typing, click, enter. Okay, that is way up there. Okay, I can tell that I did that too much. Okay, so I don't think I want it to be 1.5. I think I want it to be 1.25. Let's go back down here because I want it to be the diameter. Okay. This is why parameters are great. I can change just the things I want to change. Let's try 1.25. See how that looks. That's looking a little bit better, but still I think that's going to cause us some problems when we go to work on this. Let's go one more time with modify, change parameters, okay, and we're going to call it 1 times 1.125. We'll go 1.125. And we'll leave it at that. And we can make some changes later. Okay, so this is so far what we've got. Everything should be black. If it's not, that means you didn't enter something in. You might need to go back. Now the next part's going to be a little bit tricky. Rather than making straight lines that make the riser hard to follow, we're going to use some arcs. We're going to do a 3-point arc. Create arc, 3-point arc. Now, watch carefully what happens. I'm going to hover over the middle, not clicking yet. Go to where I'm lined up. We're going to click to make concentric. I'm not sure why this is not showing up yet. I'm going to click the other end, which is concentric to this circle. It's right about just a little above the center point. Click, and then we're going to pull that out. Now, at some point, if you're moving this around, see that tangent constraint show up? I want that tangent constraint there. So I'm going to go until the tangent constraint shows up. Perfect. We're going to do the same thing on the other side. We're going to hover over, see that little X there, click, come up just above the center point, click, and we're going to go out, and I'm going to move my mouse until I see that tangent constraint show up at the bottom of the line. Click. Okay. Now, last thing we are going to do is we're going to make some tangent constraints, tangent, and make this arc tangent to that line, and this arc tangent to that line. All right. And now we have our pear-shaped cam. Now, This again is kind of going crazy with the height here. So I'm going to make it a little bit different. Sorry that I keep doing this, but that's part of playing around with this. I can tell that this is going to have a really hard time pushing that riser. I'm going to go one more time to change parameters and make this, let's make it a little less than 1. Let's make it times 0.9. Let's see what that looks like. Okay, that's looking a lot better. That looks like something that'll actually be able to work. All right, so now that we've got this done, I'm not sure why this arc is blue. It shouldn't be blue because I can't. Oh, I know why. I need to make one more adjustment here. Okay, so we made these points across, but they aren't aligned. So let's do that. We're gonna make a horizontal constraint this time between this point and the center, and then on the other side, that point and the center. There we go. Now everything is lined up and good. All right, so finally we can finish sketch, and we're going to extrude everything except the hole in the middle. So we're going to extrude this and that to 0.25 as we've done before. Excellent. That's looking really, really good. All right, we're going to save that as pear cam. All right, excellent work so far, folks. I think we'll stop this video here. The next one is going to be how to make the snail cam, which is a little bit more complicated. So if you have time to get to that, great. If not, we've at least built 4 of our cams so far in our project. And we've got, we've made 3 of our cams. Our eccentric cam, our spinner. Oh, no, we've made 4. There's our circle cam, eccentric cam, pear cam, polygon cam. Next up, snail cam. We'll see you later for that one.